All right, so here's the video for the Unit 1 practice test, properties of functions. So starting with concept A, I can analyze graphs. So number 1 says for the graph below, does the graph have a minimum or a maximum? So remember that minimum means a lowest point on the graph, maximum means a highest point on the graph. So if I'm looking at this graph here, I see that this graph has a lowest point, and that lowest point would be right here. So this would be my minimum. So this graph has a minimum. Number 2, or part B, says find the interval where the graph is increasing. So the key thing to remember here that when we read graphs, we always read from left to right. So we always read graphs from left to right. So if we look from left to right and we're following this graph, it looks like it's going down until it hits its minimum point, and then it starts going up. So in this graph, we're going down until we get the minimum, and once we hit the minimum, that's when our graph starts going up. So if I were to highlight here where the part of the graph where it's increasing, that would be on the right-hand side. So the increasing part of the graph is right here. So if we want a little bit of a bonus, we can use what we learned when we learned about domain and range. We can write this in interval notation. So if we want to find the interval where the graph is increasing, we're going to look and see what are the x values where that's happening. Well, the x values where that's happening, it starts increasing at -3, and it's going to continue on going up forever. So in that case, if we're writing in terms of intervals, it starts increasing just after 3, because at 3 it's at a minimum, and it goes to infinity. So from 3 to infinity would be the interval where the graph is increasing. All right, number 2 and number 3, we're sketching graphs with certain characteristics. So starting with number 2, number 2 says the graph should be an absolute value function, which we know is V-shaped, so it might be V-shape facing up or V-shape facing down. Continuous means our points are connected. It has a maximum, so in terms of our V-shaped, we know that it's going to be facing down, which gives our graph a maximum point. And we know that absolute values are all functions since they passes the vertical line test. So that means our graph is going to could look something like this. So the maximum point would be right here. The fact that it is all connected makes it a continuous graph, and the fact that it is V-shaped makes it absolute value. Okay, number 3, this one's saying it's linear, so that means it's going to be a line. So that could be a line going up, a line going down. Discrete means that it is dotted or not connected. Increasing means it goes up, so it's going to look something like this, and we know that all linear functions are obviously functions. So that could look something like this. Okay, it's a line, so that makes it linear. It's dotted, so that makes it discrete. It's going up, so that makes it increasing. And if we do some vertical lines, we know that it passes the vertical line test. All right, so now let's take a look at concept B. So concept B is I can match the scenario with a graph. So number 1 says, as John gets older each year, he grows until he reaches a maximum height. So we need to identify the independent and dependent quantity in this scenario, and then we need to explain. So let's first identify what the two quantities are. So the first quantity is going to be John's age. Okay, and the second quantity is going to be height. So remember a couple things that might help us here. The independent quantity is a thing that kind of stands alone. And then the dependent quantity is a thing that is changing dependent on the independent quantity. So one way for these ones that I find helpful is to kind of say it in both directions. So do we say, does John's age depend on his height? Or does his height depend on his age? So since that second one makes a little bit more sense. So John's height depends on his age. That would mean John's height would be the dependent quantity. And that means his age is going to be the independent quantity. All right, number 2, it says sketch a graph, label the axes, and provide a scale for the given scenario. So Jane picks up her baton and tosses it in the air. After she spins around for a few seconds, the maximum height of the baton reaches 15 feet off the ground. She then catches the baton, lays it back down, and finishes her dance routine. Don't forget to add numbers to the graph. All right, so in this scenario, we need to identify the independent and dependent quantity. So in this particular situation, I see that time is one of the quantities since it says a few seconds, so that we know that whenever we have time, that's generally going to be the independent quantity. So it's going to be time in seconds. And then the dependent quantity in this case is, so it says 15 feet off the ground, so that's going to be height, which is going to be measured in feet. So let's go ahead. It says, don't forget to add numbers to the graph. So we need to scale our axes appropriately. So as we see that it's going to go 15 feet off the ground. So that means my y-axis needs to reach 15. So what I'm going to do is I'm going to go by 2s. So this is 2 feet, 4, 6, 8, 10, 12, 14, 16, and we can keep numbering if we want, but we know that at the highest it's going to go is 15. And then in terms of the x-axis for seconds, so all it says is she picks up her baton, tosses in the air. After she spins around for a few seconds, the maximum height of the baton reaches 15 feet off the ground. And then it comes back down. So a few seconds I would say is like 3 seconds. So if it reaches its maximum height at 3 seconds, so I might say that it might land after 6 or 7 seconds. So I'm going to number this by ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Okay, and then now let's graph our situation. So the first thing that happens is Jane picks up her baton. So we're assuming the baton is on the ground. So it starts on the ground and she picks it up. Okay, so maybe she picks it up, goes a little bit off the ground. Okay, next thing that happens is she tosses it in the air. So she tosses it in the air, she spins around for a few seconds, so maybe 1, 2, 3, and it reaches its maximum height at 15 feet. So she throws it up in the air, reaches its maximum height of 15 feet, and then comes back down. So maybe it takes the same amount of time, so 1, 2, 3 to come back down, where she catches it. So maybe she catches it right here. So this is where she catches it. And then it says, so that's she catches the baton, and then she lays it back down. So when she lays it back down, it's going to hit the ground. Okay, so let's just think about where the important parts up here. Jane picks up her baton, so that's this first interval right here. Then it says she tosses it in the air. So this is when it's in the air. It reaches its maximum height of 15 feet. So that happens right at the maximum point. And then it says she catches the baton. So she catches it right here. So it's still in the air here. Catches it. And then lastly, it says that she lays it back down. So here's where she's laying it back down. All right, number 3, it says write a scenario to match the graph below, label the independent and dependent axes, and add numbers and a title to your graph. Okay, so in terms of the function family, this is an increasing linear function, and it's increasing at a constant rate because it is a straight line. The rate's not changing. So an easy x-axis that we can do is time. And we can label it 1, 2, 3 seconds, 4, 5, 6 seconds, 8, 7, 8, 9 seconds. And we can kind of see that my graph is hitting kind of these important parts right here. Okay, then we have to think about something that might be happening at a constant rate. So let's take the instance of maybe filling a tank. So filling a fish tank. So when we're filling a fish tank, the y-axis would be the amount of water. Okay, maybe this is 5 gallons, 10 gallons, 15 gallons, 20 gallons. So to write our scenario, we might say Billy is filling his fish tank. every, so maybe let's pick some units here. So it doesn't really make sense for this to be seconds, because that would be filling pretty fast if we're talking about gallons of water. So let's say the units for the x-axis is going to be hours, and we'll say the unit for the y-axis is going to be gallons. So we'll say every 3 minutes, or sorry, every 3 hours, the fish tank fills, so let's see, at the first point, this is 5 gallons, and it fills up another 5 gallons, so fills 5 gallons. Okay, so that would make sense for this scenario, because that means after another 3 minutes, the fish tank would fill another 5 gallons. After another 3 minutes, the fish tank would fill another 5 gallons. So Billy is filling his fish tank. Every 3 hours, the fish tank fills 3 gallons. Sorry, I keep going back and forth between minutes and gallons, or minutes and hours. All right, now let's look at concept C. So concept C, it says, tell whether each representation is a function or not. Explain how you know. So remember, the definition of a function is every x has only one y. Okay, so let's go through part A, or number A, or letter A. We're going to look at all of the points. Okay, well, in this case, let's see, this x value is -4. It looks like there's only one value. At -3, there's only one y value. -2, only one. -1. We can also do the vertical line test. So it looks like for all of these points, that x value only has one y value. So I'm going to say yes, this is a function, because every x has only one y. All right, for B, so we could have done this for A as well. Anytime you have a graph, you can do the vertical line test. And if we did our vertical line test, we would see that vertical line only hits our graph once. But if we do that for B, and I draw a vertical line, I can see that it hits my graph twice. So in that case, that would not be a function. So we can say no, because it doesn't pass the vertical line test. All right, now let's look at number C. So this is a table. So for the table, we're going to look at our x values, and we're going to make sure that every x value has only one y value. So if we look at -2, I see that that has one y value. There are no other -2s. Next value, I see -1, and that goes to 10. However, there's another -1 in our table, and that goes to 20. So there's a problem right there, right? The x value of -1 maps to 2 different y values. So we're going to say no, this is not a function, because -1 goes, or I'll say has, 2 y values, 2 different y values. All right, let's look at letter D. So this is a mapping diagram. Again, we need to check that every input or x value has only one output. Well, as we can see here, 3, it's mapping to 4 different y values. So that's a problem, right? So this is definitely not a function. So I'm going to say no, because 3 maps to 4 different y values. All right. Number 2, we're classifying each function as each of the function families, and we're going to explain. So looking at part A, it says f of x equals x plus 3. So that's going to be a linear function. Okay, and our explanation could be that it's in the form f of x equals mx plus b. All right, part B. So part B, what I see in my equation are these bars, which are linear absolute value bars. So this is going to be a linear absolute value function. And our explanation is the equation has linear absolute value, or as absolute value bars. All right, part C. So part C, I see an x as the exponent, so that's going to be exponential. My explanation is going to be that x is the exponent in the equation. All right, and then part D, for this one, this is going to be quadratic. And the reason I can tell that's quadratic is because I have that 2. So 2 is the exponent for x. All right, number 5, it says which of the following equations could be represented by the graph. So in my graph, I see that it is V-shaped. And when my graph is V-shaped, that's going to be linear absolute value. So linear absolute value, we need to find the equation that has the absolute value bars, which is going to be graph C. So equation C could be represented by the graph because the graph is V-shaped, which is linear absolute value. And equation C has absolute value bars. All right. So now let's look at concept D. I can identify domain and range. So part number 1 says describe what the domain and range are and how you find them on the graphs. So the domain is going to be all input values a relation can have. Okay, and then range is going to be all output values a relation can have. So in terms of how do we find them, for domain, we're going to look left and right. For range, we're going to look down and up. So we're going to find the lowest point and the highest point for range, and the leftmost point and the rightmost point for domain. Okay, so first let's take a look at, for part B, we're finding the domain and range. So domain, we're going to look and see how far left our graph goes. So it looks like the furthest left my graph goes is going to be -3. And since it does hit -3 at this point, I'm going to use a bracket. And then in terms of how far right my graph goes, the furthest right my graph goes seems to be 2. However, it does not hit it at 2. There's a hole there. So in that case, I'm going to use a parentheses. For range, we're going to see how low our graph goes. Well, the lowest point on my graph is right here, which is going to be -5. And just like we said before, there is a hole right there, so it means it does not hit -5. And the highest point my graph goes is going to be 2, but it does hit my graph at 2. So I'm going to use a bracket there. All right, for number 2, we're finding domain and range again. So looking at number 2, this is a linear function. One thing to make note of is that we have arrowheads going in both directions, which means it goes on to infinity. So in terms of domain, my graph is going to continue going on forever left. In fact, it's going to go to -infinity. So my domain is going to go from -infinity, and the same thing to the right, it's going to keep going to the right. So -infinity to +infinity. For the range, we need to see how low my graph goes. Well, the lowest point that I see is right here. However, it does say it's going to continue on forever. So that actually means it's going to go forever down to negative infinity. And then for range, in terms of the upper bound, we know our graph is going, this is the highest point I see on the graph, but that arrowhead means it's going to continue on forever this way, which means it is going to continue going up to positive infinity. So my graph for my domain and my range is going to be from negative infinity to positive infinity. All right, looking at B. For my domain, we're going to look left and we're going to look right. So looking left, I see that the leftmost point on my graph is right here, but I see an arrowhead, which means my graph is going to continue going in that direction. So that means it's going down, but it's also going to the left. So for this particular graph, it's going to negative infinity. And if we look on the right-hand side, the rightmost point is right here, okay? But that arrowhead means it's going to continue on going down, but it's also going to continue getting wider. So that's going to go from negative infinity to positive infinity. Now let's look at the range. So for range, we're going to look at the lowest point. So the lowest point I see is here, but those arrowheads means my graph is continuing to go down to negative infinity. Okay, and then in terms of the highest point on my graph, I do have a highest point. I have a maximum point, and that maximum point is right here, which is at 2. So my graph's going to go from negative infinity to 2. And since it does hit it at 2, I'm going to use a bracket. All right, number C, or letter C, we're going to do domain again. So domain is on the left. So the leftmost point I see is right here, but since there are arrowheads, I know that means it's going to continue on forever. So it's continuing on in kind of the up left direction, but that does mean it's going to continue on to negative infinity. So my domain starts at negative infinity. And then on the right, this is the rightmost point. However, just like before, we see an arrowhead, which means it's going to the right. So it's kind of going to the up right, which means it's going to go to positive infinity. So negative infinity to positive infinity with parentheses. For range, we're going to look at our lowest point. So this graph does have a minimum, so it does have a lowest point, and that lowest point is negative 2. It does hit it at negative 2. And then my highest point, the highest point I see on my graph is here. But again, that arrowhead means it's going to continue on forever. So it is going to continue going up to positive infinity. So my range would be from negative 2 to infinity. All right, lastly, we have D. We're going to start with our domain. So domain, we're looking how far left. This is the leftmost point I see. But we have an arrow, which means it's going to go to negative infinity. In terms of how far right, this is the furthest right point I see, but I see an arrow, which means it's going to continue in that direction, which means that that's actually going to go to positive infinity. And then for the range, the lowest point, well, this is an exponential function, and we know that exponential functions kind of level out. So in that case, it's going to level out at 0. However, it's never quite going to touch 0. So we're going to use a parentheses. And then for the highest point, this is the highest point I see, but that arrowhead means that it's going to continue on forever up all the way to positive infinity. So my range is going to go from 0 to infinity.